A video of this presentation will be available on the chnep.org policy committee page and their YouTube channel within the next couple of business days for viewing and sharing. Next, we're on to presentation agenda item number 8. This is Red Tide and Lake Okeechobee Management with Lenny Landau. And the purpose of the presentation is to share updated research findings related to the recently adopted and implemented LOSOM protocols and possible benefits to reduce conditions favorable for long, severe red tide events. This relates to Water Quality Improvement Action 5 in the CCMP connection to support harmful algal bloom including microalgae research and monitoring and measures to proactively reduce the drivers through the reduction of anthropogenic nutrient pollution and other contributors.
Everybody ready? Okay.
Use the clicker, or I can just use your slides if you want to tell me.
Can I use this at all?
No, it has this one, or I have to do it.
Okay.
It's up to you. Just let me know
That's okay.
if you want me to do
it. All right. Anyway, good morning, everybody. Thank you for inviting me, and I'm excited to be here. And I think after I get done, you'll understand why I'm so excited, and hopefully you'll be excited. The topic of the subject is on the screen. We worked hard. Jennifer helped me with the title. We wanted to get the title right, and it's pretty simple. I'm not going to spend a lot of time on this chart, but what we're going to talk about is the relationship between the level of Lake Okeechobee and red tide on the west coast of Florida. That's it. So that's to see the level. And when we talk about red tide, we talk about the duration of red tide. And in a few minutes, I'll explain to you why we talk about duration as being the measure of what's going on. It worked. This is a chart to explain who I am and how I got here. Okay, here we are. You can read it. I'm not going to read it to you. I'm not a scientist. I'm a mechanical engineer. I worked on aircraft engines for a General Electric company for 50 years. So when you go fly any place, you're probably flying on a plane that's got an engine that I worked on. I moved to Longboat Key in 2002, and did lots of consulting work continued for General Electric, but then I did a lot of work locally with the town of Longboat Key on beach nourishment and traffic, and did a lot of work on sewer system. And then we had a red tide in 2018 that went from late 17 through 18 through 19. And you can see what it says on the bottom. The newspaper said true mitigation isn't getting rid of the algae, their mitigation is compensating businesses. Can you think of anything more maddening than that? And Moat was saying things like, experts say there's no cure for red tide. And I decided this doesn't make any sense. How can I live with it? So I spent a lot of time in my career solving problems, and I decided that even though I only had a biology education in high school, that I was going to learn about red tide. So since 2018, I spent a great deal of my time researching red tide to understand it. And the reason I wanted to understand it was, you can see it says, my mission is to mitigate red tide. I was interested in understanding it, not because I was interested in understanding it, but because you can't solve a problem until you understand what the basics are. So I've met with virtually all of the experts in the state that knew about red tide, Fish and Wildlife. Barbara Kirkpatrick is here with me today. She's, as far as I'm concerned, she's the most notable red tide scientist that I know, that I can relate to. Some of them I know and I can't relate to, but she's been a big supporter of mine from the beginning. So with that, and I just want to mention here, and I'm going to come back to it, but in 2024, we published a paper on the relationship between the discharge from the Caloosahatchee River and the duration of red tide in the Gulf of Mexico. And it was so significant, you could actually, by the measurements of the flow, we can determine how long red tide is going to last. Nobody even understood that the relationship existed, much less that you could measure it. So I'm going to tell you a couple of key things, and there are going to be a couple of key points as we go along. And if you have a question, stop me, because I think the few nuggets are really important. I want to make sure that you understand them. When I started working on red tide, I found out there's all kinds of things that are involved in understanding what happens. And I could take 3 hours talking about this chart. And you see that there are things that come from sea to land, and there are things that come from land to sea. What most people are working on is the stuff that's coming from the sea. There's the loop current and what it does. There's Senococcus, the trichodesmium. There's the iron dust from Africa and what it does, and upwelling, and you can all of this stuff. It's very complex what's going on, but basically red tide originates offshore, and then what comes from the land are nutrients, and like I show them here, coming from land to sea. You can see also there's the blue-green algae that goes both ways coming out of Lake Okeechobee, but I'm focusing on red tide. But the takeaway is that initiation requires a complex combination of these things, and the combination one year may be different the next year. It all depends on what happens. The land to sea factors only impact the duration. Okay, this is my red tide almanac, and you may want to keep a copy of this, because this goes back and looks at all of the data that Fish and Wildlife or anybody else has on when red tide occurred, how long it lasted. So what you can see is when we talk about initiation, you see on the third line, you see from September, I don't know if the pointer works here. Oh, it does. From September through November is when most red tide starts. If you think about what your experience, that's most usually when it starts. Infrequently, it may start in June through August, but usually it doesn't because the water's too warm. And then we have what I call continuation and extension. Continuation is when it starts and then it continues based on the amount of nutrients that it has. The extension is something that's new, and what it's about is that if a bloom lasts more than a year, you get a strong enough bloom that lasts longer than a year, it's still there when the next initiation season starts. That's what I call an extension. So when we talk about what happened in 2018, we had a bloom that started in 2017, but it got so much stuff that it stayed around long enough to get to the new one. So on top of the nutrients, it got that. And that's really an important point. And then we know we have a rainy season. We know we have a non-rainy season that we're suffering through right now. But if you go look at rain in the state of Florida, any place in the state of Florida, any combination of rain in the state of Florida, you'll find out that it peaks in June and it ends in September. That's what happens every year. And then on top of it, we've got a hurricane season. Does this all make sense? Everybody understand that? So red tide blooms initiate 10 to 40 miles offshore, and they're pushed ashore by wind and current. Nutrients from land can impact red tide duration when it gets near shore. And then you need to understand that Carena brevis, which is what red tide is very slow growing, and it takes from 20 to 40 days after it gets a dose of nutrients to really see an effect. So if you have a dump and something happens, that you don't see it immediately, it takes 20 to 40 days before you see it. If Carena brevis is not present, if there is no Carena brevis present in Charlotte Harbor, and it doesn't matter what you dump, it's not going to start. You got to understand that if it's not present, the nutrients coming from the Caloosahatchee and Lake Okeechobee, getting rid of water right now doesn't make any difference because there's nothing there. It's not going to start anything. So, so now let's look at how this picture starts to come together. On the left-hand side, I have a plot that came out of our report that was published in May of 2024. Jennifer was one of the members of the review team. David Tomasco was the lead author. He gave a pitch here some time ago. And you might say, I discovered this relationship. And you might ask me, well, why was David Tomasco the primary author of the paper that carried this discovery that I made? And the reason was that I'm not a scientist. David Tomasco is a scientist. And I understood that if I put out a paper, and I've written papers and articles, but it means more when a scientist works on it. So I gathered a bunch of scientists around me who not only helped bring it credibility, but also added to the statistics and to the exhibits and the other stuff. So the paper's was very well respected. And what it says is that red tide duration is correlated with the Caloosahatchee hydraulic load, which is the flow, and the nutrient load. Now, what's the nutrient load? The nutrient load is the flow times the concentration of whether it's nitrogen or phosphorus. And I know you're all interested in, we tell everybody you got to reduce the nitrogen and the phosphorus. Well, whether or not we look at the tons of nitrogen or the tons of phosphorus or the hydraulic flow, we get the same correlation. So if you reduce the flow, or you reduce the nitrogen and the phosphorus and got rid of it completely, there'd be no impact. It turns out that the flow is so overwhelming that small changes in the nitrogen and phosphorus are a little hard to detect, but they're still really important to get rid of it because it's all part of what's happening. And then things that you're familiar with, there's Lake Okeechobee. You can see S77 spillway and then S79. And now the picture's starting to become clear. Keep in mind, my mission was to figure out a way to change something that was natural. And all of a sudden, we have something going on here that says, well, maybe something's going on. So it turns out that the Lake Okeechobee discharge to the Caloosahatchee River impacts the water quality and the hydraulic load. That's what I was just telling you. S77 and S79 operations are managed by the Army Corps of Operations. And I'd say to myself, self. They're controlling it. There may be a way to do something with this thing. So to understand this, you got to go back and look at a little history. And I said in the beginning, and 1930 wasn't really the beginning, but for this discussion, we can talk about in the beginning when the flow came down the center of the state, went into Lake Okeechobee, and then through the Everglades and got cleaned up and went into Sarasota Bay. And at that time, we had red tide, but red tide initiation and duration was all natural. And I'm focusing most on the left side. And I'll tell you that red tide, as we know it, only occurs in the Gulf of Mexico, whatever you want to call it. The red tide that we see on the East Coast, it goes down past the south tip of Florida and comes up along the Gulf Stream, and that's how it gets to the East Coast. It doesn't originate on the East Coast. So the water's getting cleaned up and going south, and as a result, we only had natural red tide. And then starting in the 30s, the population grew. We put a dike around Lake Okeechobee, and then we put this spillway at S77, S79 existed. There were changes made along the Caloosahatchee River. Lots of things were done in the name of real estate and things that farming and stuff. So the Caloosahatchee River flow was altered. And an interesting one is the Kissimmee River. They got real smart. The Kissimmee River went like this, and they thought, geez, that's not really. We can make a lot more land if we just straightened it out. So what did they do? They straightened it out. The water went straight into Lake Okeechobee, and all of a sudden they had a disaster. So what did they do? They made it crooked again. So things happen for reasons, and sometimes they need to be reversed. But the situation that we have today is that the water coming down to the Lake Okeechobee goes east and west through and then the stuff that goes west to the Caloosahatchee to the Gulf of Mexico. So what we have now is red tide. Its initiation is still natural. I mean, it's still natural. However, the duration, and that's why the paper was so important, is impacted by what's coming from Lake Okeechobee, what's feeding into the Caloosahatchee River along its length, and then what we dump out into the river, into the Gulf of Mexico. Now, they tell me to use plots with non-engineers is deadly, but I have to use a couple of plots, so bear with me. I for a long time believed that rainfall, in fact, I wrote papers on how red tide comes when we have big rainfall over land. And it seemed like that's what happened. Whenever we had rainfall over land, that's what happened. So we got looking at when we had blooms, and this chart, what we decided to focus on, and Barbara helped me with this, is what I call extreme red tides. These are red tides that go through the cycle, last more than a year. And you can see we had one in 1953 that was 18 months. In 94 was 30 months, 2004 and 2017. And we said, whoo, that's interesting. Now let me tell you what this rain. When you ask, if you ask what is the rainfall, this rainfall is an average rainfall for the state of Florida. But you could look at Fort Myers or Landau or any of them. The shapes are the same, and you get the same relationship. And so I was doing this. I'm saying, geez, this is really interesting. And to show you this, everything didn't come from me. Somebody says to me, "What about hurricanes?" I said, what about hurricanes? He says, were there any hurricanes when this happened? And lo and behold, every time we had one of these things, there was either a hurricane or a tropical storm that went over Lake Okeechobee. So when you talk to the marine biologists and you talk to the experts about what does a hurricane do to red tide, and they'll tell you about how it cools the water and stirs the water up, and these things. I don't know that they're wrong, but what I know is that if they go over Lake Okeechobee and the level of Lake Okeechobee goes up, and I'll show you why that's important. That's the big impact that hurricanes have on red tide. So peak August through November. And why it's August through November is, remember I said it could take, we want to go for 40 days before, you want to go before it and after it. So if it starts in September, you got to start in August when you look at the data. So peak August and November rainfall matches up with extreme red tide events, as do hurricanes. So that's pretty interesting. Now, so then I started looking at Lake Okeechobee, and this is the level of Lake Okeechobee using the latest NAV 29 measurement. I got corrected once when I wasn't clear about what I was using, and what you can see is that when the lake gets to 17 feet, the extreme red tides we had in all those years, it always went over 17 feet. Always went over 17 feet. And you'll see there are some places where it went over 17 feet, but we didn't have red tide. Why didn't we have red tide? Because there was no Carena brevis in the Gulf of Mexico. There was nothing there. The other thing you can see from this chart that's really important, and it'll become even more important, is if you look at 1953. It got over 17 feet, but where did it start from? It started from about 14 feet. Look at 94. It started about 14 and a half feet. So the lower the lake is before you get into the hurricane season, the less likely it is to get up to these extreme heights. So Lake Okeechobee level exceeded 17 feet during the extreme red tide initiations. When it got to 17 feet, they have to discharge it because it concerns about the dike, and high lake level discharges when red tide isn't present, telling the same thing again, won't cause any problem. And that's what we got right to. I read the report yesterday. We're having a drought. They're not getting enough water down the Caloosahatchee River, so what they're asking that there be more water released from Lake Okeechobee. That's the way it is, and it won't do anything for red tide. Well, then we get into the real key to this whole thing is that if you study rain, and you will not believe how much time I spent looking at rain and trying to relate to where rainfall and what was happening. You can't do it because the rain, it may rain here, and a mile away or 2 miles away you have no rain. And it wasn't until I got hooked up with Steve Slow, who's a hydrologist, and he understood that there are measurements on the flow of the Caloosahatchee River that go back to 1937, almost daily or hourly, whatever you want, you can get it. So we put together these, and this is how we got started on it. But what you can see here is that, you see on the top chart is rainfall, and I showed the 2004 and 2017 blooms, and you can see the hydraulic load below it. See the 2004 and 2017. So in order to have a high hydraulic load, you have to have high rainfall. But if you have high rainfall, it doesn't mean that you're going to have a high hydraulic load. And that's because the flow of the river is controlled, okay? And somebody asked the question, Jennifer, I sent you a note about Ian. Ian was in 22 or 23, whatever, and it brought a lot of rain, but the hydraulic load was very low. We had a red tide season, but it wasn't crazy because of that, in my opinion. One other thing I want to point out here. This hydraulic load is in acre feet, not an acre foot deep. And if you take it, this, where I have the asterisk, is 1 million acre feet, which turns out to be 3 billion gallons a day. So I can feel that better than I can the acre feet. And I think of that in terms of a lot of what I call cleanup projects that people have, and trying to clean up the Gulf of Mexico. When you talk about little bays and that kind of canals and that kind of stuff, it works. But when you're trying to overcome billions of gallons of water a day, polluted water coming a day, it's very almost impossible to address. So this gets me down to Captain Chris O'Neill. Is that name familiar to any of you? In 2018, I'm reading in the Cincinnati paper about this Captain O'Neill complaining about red tide, and there are dead manatees. He's posting videos. He's screaming about how terrible it is. This is catastrophic. This is something that's impacting the whole population. And he was absolutely convinced that it was coming from Lake Okeechobee. Nobody would believe him, but that's what the common knowledge for, I guess, a lot of you was that something was going on here, and something needs to be done about it. O'Neill is calling on lawmakers to find a solution to the devastating impact of red tide. So that gets me up to a little while ago. And then I learned about this LOSOM, and I said, geez, the lawmakers have gotten together and they've done something. And it was implemented in August of 2024, and it's already implemented. I'm saying, whoo, this is really something. Oh, I know who's got their handle on the flow. I got to call them up and get them to go do something to reduce the duration of red tide. And you know what everybody told me? Forget it. You get all the constituencies and the voters and the agriculture and the real estate and the red tide and everybody that's interested. Nobody will do anything that isn't in the procedure. That's the way it is. So I thought maybe I'm getting close to having accomplished something, and I'm told, forget it, you can't do it. That deserves a swig of water. So here's a word chart on LOSOM. LOSOM's a big, complicated document, and it's hard to get at what's really in it. But you can read it's meant to be flexible. It addresses a long list of concerns. The central tenet of the new approach is to significantly reduce discharges, including blue-green algae, all this other stuff, to the northern estuaries, which includes Charlotte Harbor, and increasing flows south to the Everglades, which is what we want. We want to get the water going back through the Everglades. A feature of LOSOM is recovery operations to lower the lake level before the next wet season. And this is to promote for lake ecology, to get light to the bottom, and it's also for the integrity of the dike. So although implemented for lake ecology and dike integrity, recovery operations minimize the lake level during the dry season to moderate the peak level during the hurricane season. Remember that chart I showed you? I said you want to get it as low as possible so it doesn't get too high. So reducing, and this by itself reduces the nutrients going into the Gulf. So lo and behold, I don't have to call anybody. The LOSOM is already doing it, and there are things that can happen, but the whole theory of the way this thing works, it says that it's exactly. If I was to call them and tell them what to do, I say during dry season, lower the lake so it doesn't get too high during the rainy season. So here's what the news is. We're going to continue to have red tide. It starts offshore. It's going to continue to be offshore. You'll get it in the bay and wherever. But because of recovery operations, we're not going to see these, in my opinion, as I said, it can mitigate extreme red tides and shorten others by minimizing peak Lake Okeechobee levels. So if you don't get up to 17 feet, it reduces the head. So even when you reduce it, you don't get near the amount of flow. And this is really very significant. Here's this was a plot from November 30th. You probably are familiar with this plot, but if you look at the green line, this is November, December. This is where we are right now. The level of the lake yesterday was at about 13 feet. So we're in a really unusual situation because we've had such a drought. So it's getting low, and but the idea is that the bottom that we reached last year was 2 feet lower than what it was 2 years ago or a year ago, and the vertical line is when the LOSOM was implemented. So to wrap up, this is what the West Coast locals were thinking before. Red tide is coming. I hope they don't dump Lake Okeechobee again. That's where we were. And LOSOM should reduce extended red tides. If I was writing this, if I didn't have coaches and told them I'm not a scientist and we're only a year out, we got to get it. So I'll say we should reduce extended red tide booms. I'm convinced it will. We just got to give it time. And the thing that's really, the thing I wanted you to know is that this has been done. You don't hear anybody talking about it, and people talk about stuff when it gets really bad, but when it doesn't happen, they don't notice. And I think it's important that you notice that the effort that was put into doing this thing is really going to have a significant effect. We're still going to have red tide, and it may last 7 or 8 months, which is not good, but that's all natural. This stuff that we screwed up with what we did with the Okeechobee and the dams and all the pollution that we're putting in has made it worse. So we're on a good path, and I feel good that even though I didn't do it, that I can at least report that somebody did, and so that's why we're here today. So if anybody has any questions, I'll be happy to take them.
I'm just going to chime in that this is also, to me, also when you zoom out, a bigger picture message about the relationship with hydrological restoration, water quality, and the relationship of, doing what we can with regards to water management to restore as natural or more natural ways of managing the water. And that in turn can have positive benefits to the ecosystem, and in this case, even in reducing severe long-term red tide events. So the idea is, like, obviously this isn't being done as a red tide mitigation strategy, but in fact, it could have benefits with reducing the frequency of long-term red tide events. It's a little early. I think Lenny and I both, he put time will tell, and that's very accurate. We had some other factors going on. LOSOM's only been in effect a short while, and we haven't had a lot of rain, and we didn't have hurricanes. So there's some other factors at play. So we're going to keep monitoring this together over time, and can report back if this trend continues. But the idea behind it, I think, is very encouraging, and we want to,
The key is to understand that Lake Okeechobee and what's coming out of the Caloosahatchee River affects the whole west coast of Florida, all the way up to Tampa. And none of us expected that, and so if we can keep the level of the lake down, even though we had like an Ian, if you've had the water down and you don't release much, we're going to be a lot better off. So this should be a really good year. Okay.
Yeah, and just to add to that, I mean, obviously, the Caloosahatchee directly impacts the Caloosahatchee estuaries, does work its way into Lower Charlotte Harbor, but red tide, which, as Lenny mentioned, originates offshore, moves up and down the whole coast of Florida. So if we have a bloom, initiate and then bloom in our region, it could affect as far as Tampa Bay in that bloom moving up and down the coast. So it is very important that we keep an eye on this and do all we can to support. That's one of the things also that I wanted to mention is that Lenny and I talked about that, half of the nutrient load, roughly half, comes from the Caloosahatchee Basin itself. So it's not all the lake. The lake is part of the solution, but there's also basin projects, and we spend at the CHEP a lot of time and energy doing hydrological restoration and nutrient control projects in the basin as well. And all of those things combined are what it takes to address these types of big regional issues. So just wanted to put it all in context. But Lenny, thank you for doing this presentation again. And it was wonderful to co-author that paper with you all. Nicole and I were both co-authors as well with Dave Tomasco. It was a big collective effort. And we have a fact sheet online on the CHP website about it as well.
There's a view that by understanding the impact, that they can make an assessment of changes that are being made, whether it's waste, collect water or that kind of stuff. And that's true. If you're doing something to look at how much water and what it's going to do. But the other thing you can do is by looking at the how much flow you've got, you can actually read how long is it going to be, so you can get some idea of whether it's going to last 2 months or 6 months or 8 months. As long as you get something into the situation. Thank you.
Thank you. Were there any additional questions or from folks in the room or online?
So just so you know, that Caribbean doesn't like fresh water.
It doesn't.
23 parts per thousand and lower is bad for it. So it's that special spot he's talking about where they're picking up nutrients or organisms. So it's not as simple. It's another rocket science, because there's plenty of peaks that you showed that didn't have a red tide, so it's not caused by that. So I just want to clear that up.
Can I ask you a question then?
Yeah.
That there's been discussion about the relationship of sometimes the blue-green algae coming out of the lake, down the river, and with when red tide is available and present, how that interacts. Could you?
I don't think you may have a direct, but as the SNAP bacteria die, their nutrients will be recycled and available, because Carania can take advantage of any nutrients, whether they be organic, dead fish, even they take advantage of those nutrients that are released. So yeah, sure, there could be some of that, and there are times that happens. But I still don't think that makes cause an effect for red tide in general. But red tide is a big issue. I wouldn't want to be breathing in red tide.
You don't want to breathe it.
I've never actually felt I mean, I live on the coast, you know, in Fort Myers, I haven't sniffed it. I actually had it growing in my lab. But, so I was in charge of the Lake Okeechobee regulation schedule prior to LOSOM. When I was at the Water Management District, I put that in place before. Keep in mind, there's no way we're really regulating a lake that's 30 miles by 33 miles, only 10 feet deep on average. It's just not that doable. I mean, if it was, in LOSOM, the one thing you said, you were talking about special operations.
Yeah.
That, they don't do that very often. They invoked it in December of 2024, because the lake was so high for so long. They killed almost all submerged aquatic vegetation.
Yeah.
They started lowering the lake, and it came back, and it's thriving. There's Alistair coming back, and the Kara's coming back. And they're the ones that are going to pull the nutrients out, so that doesn't get downstream. But anyway, it's a tricky thing to control. You know, they don't control the lake stage. 5 feet of rainfall, 5 feet of evaporation per year, and then you check how much is actually coming up the cliffs after the St. Louis. And so they have started releasing from S77, which is the mouth. It's over at Moorhaven, probably for fresh water supply down in Coosawhatchie.
Correct.
Yeah, I mean, they have to do that. That is part of the mandate. There is a minimum flow and level for feeding that fresh water.
And they want to get the lake level down, so.
Until they did that, they were doing releases from that December until, which is a good thing. We want those plants to grow. You want the bass to come back. It's fun, complicated.
It's not easy, that's for sure.
Well, thank you both. Thank you.
Sure.